and welcome to G Fun Facts Online, your go-to spot for the most exciting bites of science and tech. Today, we're diving deep into a technology that could literally change the way our world is powered: Perovskite solar cells, or PSCs for short. You might have heard whispers about them, but trust me, these things are a big deal. Imagine a solar cell technology that has rocketed in efficiency, going from a mere 3.5% to over 26% in just a few years for single cells. And when you pair them up with traditional silicon in what's called a tandem configuration, we're talking efficiencies already exceeding 34%, with some lab results even teasing the 40% mark. That's like going from a horse-drawn carriage to a sports car in the blink of an eye, evolutionarily speaking, for solar tech. Traditional silicon cells took decades to reach where they are now, and perovskites are catching up at lightning speed. So what's the secret sauce? What makes these PSCs so special? First off, as we said, that incredible efficiency. They're already playing in the same league as conventional silicon cells. Those tandem cells, where a perovskite layer sits on top of a silicon layer, are true game changers, capturing more of the sun's energy than either material could alone. Then there's the cost. Perovskite materials can be processed using solution-based methods, almost like printing them out. This means lower temperatures, simpler techniques, and potentially much cheaper solar panels. Think about that. Cheaper, more efficient solar energy. But it gets even cooler. PSCs can be made into thin, flexible, and lightweight films. This isn't just about slapping panels on roofs anymore. We're talking about integrating solar power into building facades, windows, curved surfaces, your backpack, your car, almost anything. Imagine your tent or your jacket generating power on a camping trip. They also perform surprisingly well in low-light conditions. So even on those cloudy days, or when the sun isn't directly hitting them, they can still churn out a decent amount of power, more effectively than some traditional cells. And finally, they're highly tunable. Scientists can tweak the chemical makeup of perovskites to adjust their optical and electronic properties. This means they can be optimized for different applications and to absorb different parts of the light spectrum. It's like having a solar cell designer kit. Now, it all sounds almost too good to be true, right? And like any groundbreaking technology, PSCs do have their share of challenges that researchers are working tirelessly to overcome. The biggest one right now is stability. Perovskite materials can be a bit sensitive. They don't love moisture, oxygen, heat, or UV light, which can cause them to degrade and shorten their operational lifespan compared to the decades-long reliability we expect from silicon cells. But don't worry, scientists are on it. They're developing some ingenious solutions. One exciting approach involves embedding tiny alumina nanoparticles within the cell. These nanoparticles act like traps for iodine, an element whose leakage contributes to degradation. This has shown real promise in extending the cell's life. Other strategies include better encapsulation methods, like wrapping them in a more protective coating, engineering the interfaces within the cell with more robust materials, and even using entirely new types of perovskites, like chalcogenide perovskites. Even modifying tiny parts of the material structure, like swapping out ammonium-based components for more resilient amidium ones, is making a difference. Next up is scalability. It's one thing to make a tiny, super-efficient cell in the lab using techniques like spin coating, but it's a whole different ballgame to produce large, uniform panels on an industrial scale using methods like roll-to-roll processing. Maintaining that high efficiency across large areas is tricky. However, progress is definitely being made. Companies like Oxford PV and Renshine Solar are already making strides in scaling up production and achieving impressive efficiencies on larger modules. Utmolite even announced a global efficiency record for their nearly 3/4 square meter perovskite modules. The race is on to develop cost-effective and scalable ways to make all the bits and pieces that go into these advanced cells. Then there's the lead issue. Many of the best-performing perovskite formulas contain lead, which, as we all know, raises environmental and health concerns if it were to leak out. So, there's a big push to find efficient and stable lead-free alternatives, perhaps using tin, bismuth, or antimony. These alternatives have their own sets of efficiency and stability hurdles, but research is ongoing. In the meantime, a lot of work is also going into making sure that if lead is used, it stays put. This means robust encapsulation and developing effective recycling methods. In fact, researchers at Linköping University have developed a cool method to recycle all components of perovskite solar cells using water instead of harsh solvents, and the recycled materials can even retain their original efficiency. How cool is that? Finally, there's standardization. With so many different material combinations and fabrication methods being explored in labs around the world, it can be hard to compare results and establish industry standards. This makes commercial production a bit more complex, but it's a natural part of any rapidly evolving technology. So despite these hurdles, the future for next-generation perovskite solar cells looks incredibly bright. The pace of innovation is just astonishing. Tandem cells, particularly the perovskite silicon ones, are a major focus. They have the potential to blow past the efficiency limits of silicon cells alone by capturing a much broader slice of the solar spectrum. We're seeing new efficiency records for these tandem cells being broken all the time. The unique flexibility and potential transparency of PSCs mean we'll likely see them integrated into a much wider array of products and surfaces. Imagine cities where buildings don't just consume power but actively generate it from their windows and walls. Durability is also constantly improving. With all the research into new materials, better encapsulation, and smarter interface engineering, PSCs are steadily getting closer to matching the long lifespan of traditional solar panels. The push for environmentally friendly materials will continue to be a huge driver. The goal is not just lead-free perovskites, but also sustainable manufacturing and recycling processes from start to finish. And guess what? Artificial intelligence and machine learning are playing a role too. These powerful tools are being used to design new materials, predict their performance, and speed up the discovery of even better perovskite compositions. There's even research into combining perovskite cells with concentrator systems. That's where lenses or mirrors focus sunlight onto a smaller area of solar cell. This could boost efficiency even further and reduce the amount of material needed. As research and development continue at this breakneck pace, perovskite solar cells are absolutely poised to become a major player in the renewable energy sector. They offer a pathway to more efficient, more versatile, and potentially much more affordable solar power for everyone. Some projections suggest that commercial-scale production could become widespread in the early 2030s, with costs expected to drop significantly. So keep an eye on perovskites. They're not just a lab curiosity anymore. They are rapidly marching towards a future where they could help power our planet in cleaner and more innovative ways. That's all the time we have for today on Fun Facts Online. Thanks for tuning in, and we'll catch you next time with more fascinating facts from the world of science and technology.